Hey there, and welcome to U Talk. We highlight stories from across Canada, the diverse cultures and communities living here, and organizations and individuals that help make life the best it can be. I'm your host, Ryan Funk. Life on Earth is unbelievable. There have been 1.2 million species that have been described on this planet, and an untold number that once lived here. It's up to dedicated scientists and students who spend their careers seeking to learn more about life millions of years ago. Dr. Femke Holwerda is one such scientist. As the Dr. Elizabeth Nicholls Postdoctoral Fellow at the Royal Tyrrell Museum, she studies the diet of mosasaurs from the Bearpaw Formation in southern Alberta.
Sure, well, thank you for having me, first of all. So I'm now a postdoc in paleontology. I'm the Dr. Betsy Nicholls Postdoctoral Research Fellow here at the Royal Tyrrell. And it's been a bit of a journey for me to get to here. I always wanted to be a paleontologist ever since I was 3 years old. So after high school, I went to university, like more or less everybody will do. I picked biology at the advice of a Dutch paleontologist at Naturalis Biodiversity Center. He said, either you want to study the rocks or you want to study the animals. And he said, if you want to study the animals, biology is a better way of getting into paleo. And I thought, I'm more interested in the living animals, or studying dinosaurs as if they were living animals than just the rocks they're from. So back then in the Netherlands, there wasn't really a paleontology master's, and there were a couple of programs around Europe, but I didn't really know that much about them. So I decided to stay in the Netherlands and do my master's there as well. So I did biogeology, which is it approaches paleontology, but it's still not the perfect, and I think nowadays they have a master's. So I just missed out like a couple of years after my time. They started a master's program now. And then I kind of drifted for a couple of years because it was hard to find a PhD position. It still is. It's like you have to really land either a grant or somebody who has a grant or who has just, research money. So I actually worked in a geochemical lab for a year as a research assistant, working on stable isotopes on rock layers. So that was pretty cool. I think that gave me a good sort of geochemical background, which I still use in my research now. So that was good. Then I worked for a year as sort of semi-preparator, semi-researcher on a dinosaur egg project in Portugal, which is really cool. Yeah. And actually, that was supposed to be for 2 years, but after 1 year, I got my much desired PhD position. So then I went to Germany to do my PhD on sauropod dinosaurs, long-necked dinosaurs. And then, after that, I had basically a short postdoc project in Germany, and then I landed this one. So that's kind of, been all over the place.
Well, that's super cool. And at the beginning, you mentioned Dr. Betsy Nicholls, correct?
Yes.
Oh, that's so cool, because she holds so much significance at the Canadian Fossil Discovery Center, where I have a lot of experience with. So that's super cool, just to, the world feeling even smaller once again.
Yeah, she was a powerhouse. I really wish I could have met her, but it's nice that we have this postdoc named after her, and so we carry on her legacy, hopefully.
Yeah, and it's just the impact that she had in paleontology is so amazing. And it seems like just women in general have had such a significant impact on this study, though many don't get the recognition they deserve. Because I can't remember her name right now. The lady who discovered the ichthyosaur out in Britain,
Mary Anning.
Yeah, that's it.
Historical figure, yeah.
So cool.
There's a really great kids book about her now as well that I was thinking of getting for my kids who will be born in September. I thought that's like a nice sort of example of women in STEM, women in paleontology.
Yeah, it's awesome. Yeah, it's been a boys' club for so long. Like, just it's great to see these women who are integral to this study. Finally getting this recognition. I think there was also a movie about her. I think it's called Ammonite or Ammonite. I can never
Oh,
say that right.
Ammonite. Yeah, I haven't seen it yet actually. But I heard it was good. Yeah.
Getting back on topic, for those who are unaware, we've talked a lot about like dinosaurs and fossils, but what exactly is paleontology?
Right. So paleontology, sort of, if you break it down, it's ancient Greek for the study of ancient beings. So I think that that's a good distinction already from archaeology, which is kind of like the study of the ancient people. So basically, paleontology studies past life on Earth, and it could go into deep time. It doesn't necessarily have to, but usually it is kind of like, yeah, you're talking about past life of like several million years ago, up to all the way to the beginning of life on Earth. And then, of course, vertebrate paleontology distinguishes itself by studying only vertebrates, so everything with the spine. So that's kind of like everything from fish and over, all the way up to dinosaurs and mammals.
I think just for myself, paleontology is just so cool to think about life before us. Just when you see these bones, just in your imagination, what would they have been like in real life? That's just always what I'd love to see, like a real animal like from back then. It just it gets me so excited to just think about.
Yeah, it's such a shame that we can't really transport ourselves in a time machine to like a little Jurassic ecosystem or something, or like a Cretaceous sea.
Because like you see the paleo art and all that, but it just never does it justice. Like, you can see elephants out in Africa, but being able to see a sauropod would just, it'd be mind-blowing.
Oh man, yeah, I hear that ground shake as they kind of walk by. Yeah, or well, I always kind of say like you wouldn't want to snorkel with a mosasaur, I guess, but maybe on like a boat where you can see the sea floor through, and then go on sort of a mosasaur cruise. That'd be cool.
Just an aspect that unfortunately we'll never be able to experience, but we can learn a little bit about them from their fossils left behind. So what about you? You tell us about that. What exactly is a fossil, and why do we study them?
So fossils are basically the remains of these past animals that we just talked about. And there's different categories of fossils, but I think most people will know bones as fossils. So that's basically the bones of these old animals that have turned to stone over the course of millions of years. There's a specific mineralization process. I won't go into the details because that gets tedious. But basically they take home messages. They turn into stone. They fossilize. So next to bones, you will have actually other bits of evidence they left of their life on Earth, which is footprints, for instance. Footprints can remain preserved, especially if they walked into wet mud. And then there's also other imprints, like imprints from feathers or skin. And if you're really lucky, you might find a little bit of soft tissue preserved, but that's very rare. We do have a beautiful little mosasaur here in our collections that has some stomach content preserved and a little bit of skin. And that's really cool, but that's really rare. The reason why it's rare is because an animal died millions and millions of years ago, and then got exposed to everything, the weather, the different climates, different landscapes even. And then, so you're actually really lucky if you find something nice. Usually you just find kind of bits and pieces that are left, and then it's up to us to puzzle those back together. But we study them because they are the only thing that will give us information about these past animals on Earth.
I think another interesting part about paleontology and learning about the animals' past lives, I can't remember, what is it, carbolites, the fossilized dung?
Oh, coprolites. Yes.
Coprolite. There you go. Thank you. I was like, I think I remember the word. Can't quite. But I think recently they discovered like a new beetle species from one. So like that's
Oh,
another
yeah.
aspect. Super cool.
No, that is a fun one to kind of study their fossilized poop, basically. Yeah, and then that can sometimes also say something about the species diversity if you find different types of poop. It's like, oh, it's different types of animals lived here, even though maybe their bones won't be found. You can find their,
You
yeah,
can find something, yeah.
yeah.
It's super cool. And on the topic of soft tissue, I know in kind of recent years there's been a lot of, not a lot, but like a few examples of creatures with soft tissue. Like there's a mummified hadrosaur, or like that's what people are calling it, which is super cool. I can't remember exactly where it's on display, or at least in
Oh, it is
study.
here in Canada, isn't it? Yeah, with the skin really nicely preserved.
And there was like a foot and had like a fingernail on a different one.
Oh,
There's a lot of cool things, and I think
yeah.
that one of the coolest examples is the nodosaur at the Royal Tyrrell Museum, which I
Oh,
got to see, and it is so cool. Like it's so
it's
well
pretty.
preserved.
It's really well preserved. I mean, it was a preparator's nightmare. It took, I think it only almost took 10 years to prepare, but it's so worth it because it's so beautifully preserved. And yeah, you can see everything in detail. And I think recently they had some stomach contents also from it analyzed. And so you can see what it ate. And yeah, no, that's like you win the jackpot if you find something like that.
How about you go into a little bit detail there? Like, it's not just going into the field and finding these remnants of creatures long past, but there is a lot of manual labor that goes into
Absolutely.
paleontology.
It's a whole process. Yeah, it's nice that you ask because I think a lot of people don't realize that you find the fossil in the field and then you go on the cool field work, you take it home with you, you take it to the collections, and then the real work starts. Then the preparators will have to painstakingly get it out of the rock it's embedded in, with little pneumatic drills, with little dentist tools if it needs to be really fine work. So I don't have the patience for it. I'm really glad that we have really good preparators who are really skilled and who have this patience and who will just work on this for months in a row or sometimes even years, and that gets the best results. And yeah, and then you have the animal or the specimen ready for study. So then the real research starts, and that takes a while as well, describing it first and taking the pictures and seeing what it's related to, and yeah, analyzing stuff. So yeah, from basically finding something in the field to the, let's say, the end product, they can either go in the exhibition or it's just nice enough to study. That, yeah, that sometimes takes several years before that's done. Yeah.
Yeah, it's a very involved job.
Yeah. No, absolutely. And you need to have a long breath for it, right? You need to just be patient and yeah, see it happening. For instance, just now a mosasaur skull is getting prepped for my research, and it's really cool. But it's yeah, will take some time. So I love going down to the lab and see it happening, and then more and more bones are starting to appear, and it's really exciting. But it will take some time. Yeah.
I remember when I volunteered at the CFDC out in Morden, like working on some of the material. Like just, I think out here in Manitoba, we get a lot. I think the mineral's called gypsum. Like it's like that clear crystal like mineral, and it is such a pain to get off of the
That's
fossils
bad
here.
news if you have to. Yeah.
Yeah, we get a lot of that on the fossils out here, or like putting, it's almost like a puzzle sometimes because you gotta like super glue some of the
Right.
materials back together because it just falls apart.
Oh man, yeah. If you have like, we have these nodules, for instance, which are just like bits of hard rock, and then a bone is embedded in there, and they are in pieces. So first you have to puzzle those back together and then prep it out. And yeah, I think I almost got anxiety about it. I was like, I'm so glad I don't have to do this because I wouldn't even know where to begin. But yeah, these people are just so skilled. They get it done. Yeah, and becomes beautiful.
So looking back on your research, yeah, you studied sauropods from back in the Jurassic and like some eggs. What brought you to mosasaurs? And we can talk a little bit more about what those are exactly afterwards.
Yeah, sure. So, I'm from the Netherlands, and the very first mosasaur is actually from the Netherlands. At least the first historical mosasaur found to humankind. There's a skull found in the south of the Netherlands, and it's actually now still on display in Paris in the Natural History Museum. But so if you're from the Netherlands, that's kind of if you're into paleontology, that's the only kind of Mesozoic fossil we have. There's another site which has a little bit of Triassic in the east. But that's about it. So if you're into paleontology and you're a Dutch kid, you cannot go around mosasaurs. Basically, you will get into mosasaurs. So yeah, and I did a little project. This was actually between when I was kind of hunting for Ph.D. jobs. Me and Anna Schulp, who's a Dutch paleontologist, did a little project on mosasaur teeth from this. It's called Maastricht. It's actually the end stage of the Cretaceous is named after this town. So it's these Maastrichtian mosasaurs. And so that got me into mosasaur research, really. And then I decided to expand that for my job application for this current job. So I was like, well, they have great mosasaur specimens at the Tyrrell. I know a little bit about mosasaur research, and I do mosasaur teeth. So yeah, I went on to doing that.
We talked about dinosaurs a little bit, and now we're talking about mosasaurs. What's the difference between them?
Oh yeah, well, whole score. So that's good also because people always say, mosasaurs are dinosaurs, but mosasaurs are not dinosaurs. Mosasaurs are actually more closely related to lizards and snakes than they are to dinosaurs. So they're basically a type of varanid lizard with flippers. That's what I call them, and a tail. And they were completely marine. They lived in the late Cretaceous when the sea was nice and warm and tropical, so it was a good time to be a reptile in the sea. And they were probably the top predators in all of the ecosystems they inhabited. They became very successful as well. You can find them everywhere around the world. Some even in freshwater, but mostly in just marine settings. And so it would have been a bad day if you were the prey of a mosasaur because they had these really powerful skulls and lots of teeth. They even had teeth on their palate, like some snakes and some lizards have that as well, which is, it's very cool, but it's also ultra scary if you're a prey. It's kind of to get the prey more into their mouth. And dinosaurs were more are this specific group of reptiles that lived on land. So they're only related very way back, to a common ancestor, way before the Mesozoic era.
I think mosasaurs are just so cool. Just basically lizard whales.
Yeah. And they were completely marine as well, so they probably never came on land. So we don't know exactly how they reproduced, for instance, but there's speculation that they might have done live birth, just like what whales and dolphins do in the sea. And they were just really successful with their big bodies. They got up to 12, 15 meters of length, which is insane. I mean, they're not as big as the ones you see in Jurassic World, because that one is just blown out of proportion. That one's way too big.
Media's involvement in paleontology and dinosaurs may skew people's opinions a little bit about what they are. I think one of the biggest one is when I learned that velociraptors weren't as big as the ones in the movie, and most people, the consensus is they were completely feathered.
Yeah, exactly. Yeah, those kind of things. And also I think the brachiosaurs, they made them way too big, and the T-Rex is probably not as fast as we see him. I mean, it's the films are great, but it's like
Yeah, but at least dinosaurs getting some representation, right?
Right?
Like at least there's
Yeah.
some. I wish
No,
there
absolutely.
was more. But what can you do? What can you do? So I guess one of the big questions is mosasaurs. They're these massive marine apex predators living in the oceans. Why are we finding bones of them like here in Manitoba or out in Alberta?
All right. Yes, that's because back in the Cretaceous, about 75 million years ago, a huge part of North America was covered by a big inland sea called the Western Interior Seaway. I do not have a picture of it here, but it basically split the whole continent in half. So you had two big land masses, and in between this large sea, which would have been a little shallower towards the shore, where lots of fish would live. So that was ideal mosasaur feeding and hunting grounds, and nice warm water, because it was a greenhouse world in that time. So there was no sea ice, no ice on either the North or the South Pole. So nice and warm, good for being a reptile, nice and tropical, lots of food. And so you find a lot of mosasaurs from this sea, all the way from the south, like I think Louisiana, Alabama, all the way up to us here in Canada.
So a very different world, not just with these
Absolutely.
creatures, but just the geology of it as well was completely different.
Yeah, no, true. And I think you can imagine if the ice is all melted, then you have a much higher sea level. So a lot of land in the Cretaceous was covered with shallow seas. It's like if we maybe we grab that later, if we grab a map of the world, you have this big interior seaway in North America. You have big parts of South America also having the sea covering them. I think North Africa is also just half gone. Europe is definitely gone. It's not on the map. Just some islands. Yeah. So actually, a really good time to be alive, to be a marine reptile.
Yep, yeah, and there were like when we're talking about the diversity of them, I think it's called the Chrysiodon puntlagensis. I think I remember that name. That was found out in BC. We got an exhibit of that at the CFDC,
Oh,
and
cool.
another one, the Tylosaurus pembinensis. We got Bruce, which I think is the Guinness World Record holder's the largest publicly displayed mosasaur.
Oh,
And
nice.
out in Miami, Manitoba, we have the holotype of the Tylosaurus pembinensis that was described by Betsy Nicholls.
Cool. I'm really jealous of you having a nice tylosaur, because we don't really have that many tylosaurs here in the collections. Yeah, but you get the nice one.
Yeah, we got some really nice fossils up here. I think we have a lot of like plesiosaurs and elasmosaurs, but a ton of mosasaurs, specifically these Tylosaurus ones. And Bruce is so big. Like, being next to him, you're like, whoa, this is a monster.
Like, again, don't snorkel with them. Like, just
don't
take the cruise.
Don't snorkel. But it's just so cool. Like, paleontology just shows us a world that doesn't exist anymore. And we're talking about just a really small portion of, life in general.
Absolutely, yeah. They got so big, it's insane. They were really they outcompeted more or less everybody else for marine dominance, except you had some plesiosaurs and some sharks, and I think that those were like the other big marine creatures around them, and then there was just these mosasaurs everywhere. Yeah.
What other kind of research are you kind of doing right now? Is it just kind of focusing on the teeth aspect, and what does that research look like?
I mainly do this research on mosasaur teeth. So you might wonder, okay, you've got these awesome, really big mosasaurs. Why specifically focus on just the little teeth? But that's because teeth are very abundant in the fossil record as well. And also when you don't have bones sometimes, as I explained before, they don't always get preserved. Teeth actually preserve a little better because they're so hard. Like we've got hard teeth as well. You can imagine that will preserve a lot better than bones. And then teeth can say a lot about an animal's diet. So I use these teeth, both their morphology, so the way they look, and also the micro scratches, the micro damage on teeth from different diets, and some geochemistry, which is kind of still because of my time in the lab way back when, to reconstruct mosasaur diet here and to see if they coexisted next to each other, because you have all these different types of mosasaurs, or if there would be some overlap in ecological feeding niche, we'd say. So basically their feeding corner of the food chain. So I'm trying to figure that out. So that's really cool. And then of course I did my PhD on something completely different, on these long neck dinosaurs, which I still kind of do in the background every now and again. So yeah, I did dinosaurs and now I do mosasaurs. But yeah, so I don't do both at the same time, because then you get confused, because you have your marine animals and your land animals. But so with these long neck dinosaurs, I mainly do the early evolution of these guys in the early middle Jurassic. So that's about 170 million years ago, whereas these mosasaurs, they're like more like 75 million years old. So that's about 100 million years difference between the two.
Yeah, and I mean, it doesn't get boring. You're learning about two completely different kind of like groups of creatures.
Right, everything is interesting. Yeah, I mean, you have to at some point specialize into something. But yeah, I think everything in vertebrate paleontology, especially in the Mesozoic, for me is very interesting.
Coming back to just paleontology as a whole and kind of working in STEM, we've talked a little bit about Mary Anning and, how for years her contributions to science were just not recognized. Have you faced any challenges as a woman working in STEM and someone, from the Netherlands coming here? Have you faced any challenges, or has, the environment kind of become more welcoming?
I think it's getting better and better for women in science and women in paleontology. There's definitely still challenges to be had. I think if you look at the numbers of students who will enroll in a bachelor's or master's course, everything is still quite evenly distributed in terms of gender. Mm-hmm. And then if you look at PhD numbers, and especially postdoc numbers, so basically after first getting the specialization into a doctor's degree, and then in the postdoctoral phase, you see this massive, we call it the leaking pipe. You see this decrease in women basically who just leave the field mostly because they either feel they're not supported, or they will have families and that is not supported by the system. Mm-hmm. So there's definitely a lot of work to do still, but I think it's getting better and better. For myself, I've been feeling very welcome here in Canada. It was relatively easy to get a work permit, and I feel really at home here in the Tyrrell, and everybody's been really supportive. So of me as a woman in paleo, so that's great. I still do a lot of work. I run the Women in Paleo group for the European Association of Vertebrate Paleontology, which is now all happening online, of course, because we're all still in a pandemic. And I think it is important for women to kind of help the younger generation but it's also definitely, of course, the established people who are, the great majority of which are men. I think they have a lot to gain with supporting the younger generation getting into paleontology. So yeah, it's there's still a lot of pitfalls, but I think it's definitely better than, let's say, 10, 20 years ago. Having said that, I think the pandemic kind of messed things up a bit for women in science. There was a paper out recently, I think, on a study where it showed that because women still get the majority of caring tasks, either paid or unpaid, a lot of women during the pandemic, because of the lockdown, actually lost out on a lot of opportunities to publish and to do research. And you can now see that there's this big discrepancy between male and female scientists' output. So I hope that will recover, after now that it's, I think it's kind of like, it's 50-50 whether or not we're recovering from the pandemic or if it's going to last a bit longer. I think it's looking good so far, fingers crossed, that the world's opening up again. But yeah, that's definitely an issue, I think. And I hope, that, that won't last, that sort of backlog. Yeah,
it's definitely a kind of a conversation just about societal norms, like you mentioned, females taking on more of those caring roles that, in terms of like familial units, maybe the distribution of like caring time needs to be equalized. And just, I think just seeing women in kind of leadership roles in terms of like science is great for getting like young girls inspired to join science. Because for a long period of time, like you just see, when you picture scientists, when you close your eyes, it's usually just a white guy in a lab coat.
Right.
So definitely diversity is greatly needed, and I think just opens up new aspects for ideas and what people want to study, because paleontology, there's so much.
And I think it's exactly what you say. It's like the more you normalize all these different types of people who are scientists, and as you say, not just the dude in the lab coat. I think the more you normalize that, the easier it gets, and the more you combat these stereotypes that kind of persist. And that force people into certain roles over periods of time. I think that's really important to just, get everybody out there.
So what advice would you give someone who's maybe listening to this conversation and has been inspired to learn more about paleontology, or maybe they want to study paleontology themselves? Maybe they're heading into university and they're like, oh, this sounds like something cool. Or someone overseas that wants to come study here in Canada, because we have tons of amazing specimens and different species that can be found here.
Yeah, so I always tell people, just go for it, right? It's it might not be the field where you earn the most money with, but then I guess if you want to earn lots of money, you have to maybe just become a lawyer or something. But if it's your passion, if you're excited and enthusiastic, then definitely go for it. It's there won't always be a job immediately for you, but if you persist, I mean, look at my background. I kind of went all over the place, but it worked out in the end, and I could use all those skills that I acquired in the end as well. So just go for it. Probably connect with your local museum is a really good way of starting. For instance, the Tyrrell, and I guess your museum as well, will have lots of programs for young people and kids to engage them into science. So that's usually a really good place to start. If you want to come to Canada, I mean, my experience has been really positive coming to Canada. I think, we've been, it's really crazy because I started my postdoc literally a couple of weeks before the whole world shut down. And I didn't know it at the time. I was kind of naively thinking, it's going to be fine. So we flew in to Canada, and I think 2 weeks later, everything shut down and all the airports closed. So for me, it's been doubly nice because I felt really safe here during the pandemic. which was crazy. But yeah, I think, we've got a lot of great collections, and I think, everything works, right? Like the local people who study the fossils will add to the research, as well as international people. So yeah, and I think paleontology is a very international field. I think especially the newer generation of scientists, they're all about cooperation between different institutions, which is really nice because that only makes research better. So yeah, I think, my advice would be, go for it, connect to your local museum and your local specialists who can help you with their network, probably. And go to maybe, start small with the smaller conferences. If you feel confident, you can go and talk to people. Maybe don't immediately go to the really big ones if you don't know anybody. That can be a bit intimidating. But usually get somebody to help you a little bit, to mentor you a little bit. Yeah.
Awesome. And finally, I mean, you've studied both sauropods and now mosasaurs. If you could research anything in terms of paleontology, what would you want to research?
That's a good question. So I think when I started, I really wanted to study theropods, like big theropods, like Tyrannosaurus, like Giganotosaurus, I think, who's now going to be making an appearance in the latest Jurassic World franchise, from what I saw. So I actually am studying a little bit on isotopes on teeth of Spinosaurus, which, and that's he's been in the news quite a bit recently.
Controversial or otherwise.
So I kind of got to do those. It's been it's a wild ride sometimes with when an animal becomes a popular studied dinosaur. Everybody will suddenly study them. But so I got to do that a little bit, so that's cool. Another thing I really want to do is pterosaurs. I think they're pretty cool.
Oh, pterosaurs are awesome.
They're so weird though. Their anatomy is really, really weird. But yeah, that makes it really interesting. I think that's the nice thing is, if you connect with a lot of people, you get different research ideas, and then you start to end up in more, in a variety of projects. So yeah, that's another nice thing about paleontology, I guess.
If you have any stories you'd like us to share or communities we should highlight, leave a comment on our social media or reach out to us on our website. I'm Ryan Funk. This was U Talk, and have yourself a good one.